Good evening, Austin. I'm Ryan Tazumi.
And I'm Daniel Tovar.
In today's top story, 2 years ago in Harrisburg, Pennsylvania, a commercial nuclear reactor at 3 Mile Island partially melted, leading to the first nuclear accident in the United States.
As the incident developed, miscommunication between state and federal official operators and first responders led to confusion. With lack of the information from these sources, the media filled in details which led into chaos and confusion in the public.
As a result of the information fed to the public by the media, a public distrust in nuclear energy has grown. Today we welcome Manny Morales, a TMI inspector, to help shed light into what really happened that morning of March 28, 1979.
Thank you, Daniel and Ryan.
Manny, could you please explain to us what really happened at TMI?
Be glad to, Daniel. In order to help with the explanation, we'll be looking into this diagram. The chain of events began with the valve failure in the secondary non-nuclear loop of the reactor, resulting in a leak. As a result, the remaining water boiled off due to the increase in temperature caused by a lack of water flow. This resulted in a loss of steam to the turbine, which immediately shut off, causing the pressure in the primary nuclear loop to rise. The rise in the pressure and increase in temperature in the first loop led to an automatic shutdown of the reactor by full insertion of the control rods. Almost simultaneously, the pilot-operated relief valve for the PORV on the pressurizer opened to decrease the pressure in the reactor core. The PORV should have closed when the reactor reached a safe pressure level, but it remained stuck open, leading to a loss of coolant accident. Operators were unaware of the leaking coolant since the instrumentation told them the valve was closed. As a result of the leak through the pressurizer, the primary loop emergency feed water pumps turned on to restore the coolant in the system. Due to the speed water, the pressurizer water level began to rise despite the leak, which alerted operators. Their training told them that the only indication of water level in the reactor was the pressurizer water level. They were also trained to prevent the pressurizer from filling up completely with water. As a result, operators slowed down the feed water flow. The temperature rise in the primary loop due to the inability to remove heat caused the remaining water in the core to boil off, which led to the steam and the zirconium cladding to react. The cladding ruptured and exploded the fuel, causing it to partially melt down.
Wow, a partial nuclear meltdown sounds really bad. What does it mean? And what were some of the consequences from this?
Great question, Ryan. A partial meltdown describes the event in which the fuel rods become slightly exposed due to a lack of coolant, which leads to the release of nuclides into the coolant and containment structure. As opposed to a full meltdown, which causes the fuel to melt entirely into a lava-like pool, which can breach the containment vessel, a partial meltdown does not breach containment. This implies that radionuclides can still be contained. However, in TMI, the radioactive gases that built up in the makeup tank in the auxiliary building had to be moved to waste gas tanks. During this process, the compressors leaked, causing the nuclides to be dispersed. However, the filtering system on the building blocked most of the nuclides except the noble gases, which escaped to the environment. Since these noble gases have a short half-life and are inert, they pose no health concerns to both public and environment.
So what have we learned from this incident? Is nuclear power too dangerous? What prevents other nuclear power plants from completely melting down?
As you guys mentioned in the beginning, the seriousness of this event escalated due to the miscommunication and bad media, and not the event itself. There were confusing telephone calls between officials, some of which rumored that a hydrogen explosion had occurred and evacuation was needed, and some which reported high counts of outside radiation when the counts were actually from above the building. One of the lessons learned was how to communicate more efficiently during an event like this so people at stake have the correct information. Also, like other power generation technologies, they are dangerous if not controlled and monitored properly. The 3 Mile Island accident was a culmination of operator error, faulty instrumentation, and communication. The operators were not trained properly, and the instrumentation in the control room and key mechanical components did not help the situation. As a result of this incident, better operator training programs are being developed and more robust components and signal instrumentation are being engineered. With the development of these new programs, we can have a proactive culture instead of having a reactive one, which will prevent incidents like this one from occurring again.
Okay, so hopefully this sheds some light on the true story. Well, that just about wraps up this story. From all of us here at Channel 9, I'm Ryan Tazumi.
And I'm Daniel Tovar.
Stay weird, Austin.